We're live, and we'll continue with heap and priority queue tasks. And let's take a look what we have for today. So our next task would be about mice and cheese. So let's see. So there are 2 mice and n different types of cheese. Each type of cheese should be eaten by exactly 1 mouse. A point of the cheese with index I, 0 indexes, is reward I is the first mouse eats it. Reward 2 if the second mouse eats. You are given a positive integer array, reward 1, a positive integer array, reward 2, and an integer k. We have to return the maximum points the mice can achieve if the first mouse eats exactly k types of cheese. So we have reward 1. So it means if the first mouse eats 1, 1, 3, 4, it will get reward. If mouse 2 will eat 4, 1, 1, it will get reward. And we see that first mouse eats 3 types of cheese, and we have to return the maximum points the mice can achieve if the first mouse eats exactly k types of cheese. So, in this example, the first mouse eats the second 0 indexes and third types of cheese, so 3 and 4. And the second mouse eats 0 and first types of cheese, like 4, 4, 1, 1. And the total points are 4 plus 4, 3 plus 4. So we have here 2, 4, and here 3, 4. So actually what we need to get k2, so 2 maximum values from here and 2 maximum values from here or not. So for example here, we have 1, 1 and 1, 1. And in this example, the first mouse eats the 0 indexes and first types of cheese. And the second mouse doesn't eat any cheese. It can be proven that 2 is the maximum total points that the mice can achieve. Not sure that I quite understand the task, so we have some rewards. There are 2 mice and different types of cheese. Each type of cheese should be eaten by exactly 1 mouse. But here we have like 3 types of cheese, and we should return the maximum points the mice can achieve if the first mouse eats exactly k types of cheese. So in this example, first mouse eats the second and third types of cheese, so 3 and 4. And the second mouse eats zeros and first types of cheese. So it's indexes, right? The point of cheese with index I. Yeah, and the mouse second cannot eat more because, so it's indexes. All right. So actually what we need to do is to find indexes, right? K maximum elements from here. So from here we found like 3, 4 is the maximum. Then 4, 4 is also the maximum. So what we can do, is to find k values from here and k values from here. And k values from here, and not the same as in the second. So return the maximum points the mice can achieve if first mouse eats exactly k types of cheese. So we always know that first mouse would eat maximum numbers of cheese from here. So what we can do is to find k number of cheese and to store indexes that we cannot get. Then we can also, okay, so now I think I understand. So let's talk about solutions in our case. So the first solution, we can sort first array, then take k numbers and store indexes. Then we sort second array and take k numbers without previously taken, and actually return. So it's our algorithm, and so let's call it sort AB, and this algorithm actually works as maximum from n log n and m log m time complexity. And space complexity is actually constant because we are not getting anything. So actually we just sorted, and that's it. Okay, so let's try to implement it. So what we do? So first we do arrays dot sort of reward 1. Yes, and then we have our results, and also we have a set of indexes we have set of indexes that set of indexes that actually we should be not consider into our next mouse. So when we sort our array, actually, we also don't have now information about indexes. So what can we do is not sort this rewards array, but to have a kind of record of pair where we have index and value. Yes, and we can sort this array by value. So let's create this array. Let's call it pairs array 1. And it would be reward 1 length. Then we have iteration here. Reward 1 length for I++, then check reward I int value. Yes, and we create our new pair with index I and value, and we put this new pair under pairs array with I. We put this value, and then we do arrays.sort, and we are sorting this pair, and here we have our comparator I and j, and we actually take I value and j value. So we have our sorted pairs array. Now while, so let's say another loop, int I equal 0, I is less than k, I++. So we actually do k times getting values from this array. And we can start from the beginning. So we get, first our pair, and we can, what we can do, we can put into our indexes our pair. So we can put our index, yes, that we used, and we can also add into our result value. The same we should do for reward too. So we can do something the same, but here it would be 2, 2, 2, 2, 2. Okay, and now we sort it as well. Yes, and now we are taking these key elements, and with these key elements we actually are taking this pair, and if set contains p index, so if it's not contained, then we can add into our result another value and return results. Yep, so looks promising. Let's run it. So what do we have? Pair can be converted to int. Yes, because here it should be pair, and here as well. Okay, set, cannot find simple set indexes. Yes, should be indexes. Okay, so we have k output 4, but expected 15. Interesting. Here we have 2. Okay. Indexes PID 2. Yeah, probably here should be thing J and I, and J and I. And now submit. Okay. So here we see k equal to 3. So we can take 4, 5, 3. But we see that if we take this 3, yeah, so here we actually should consider what exactly 3 we should take. Yes, because if we take a look at this example, and it's a very good example. So we first sort our array like 5 with index 2, 4 with index 0, 3 with index 3, 3 with index 4, and 1 with index 1. Yes, and then we sort this array. It would be 5, 5 with index 3, then 4 with index 1, 4 with index 2, 3 with index 0, and 2 with index 1. Yes, so if we take these first 3 values, so we have 2, 0, 3. Yes, so we took these 3 elements. So if we take these 3 elements, then we cannot take this 3, this 4, and this 5. But we can take 4, 4, and yeah, because if we, for example, take this 3, then 2 with index 4. Yeah, so yeah, so if we have multiple ones, we should take here the index with lowest value from here. Like we take this 3 and we check, okay, so this 3 have 5, here 4, this have 2. So for sure we should take the minimum from them. So what we can do, here, so we should take values from the first array. Yeah, we should actually compare the maximum. The maximum, because return maximum points the mouse can achieve if the first mouse eats exactly k types of cheese. So it doesn't matter actually what types of cheese it can eat. Okay, cool. So what we can do? So we have 2 arrays and 2 indexes. So so what if we will merge all these 2 arrays actually into maximum what we can get? So if we will merge this one, we can see like 4 and 3, we can have 4. Then 1, 4, 4. Then 4, 5, we can 5. Then 3, 5, 5. Then 3, 2, 3. Yes, and we have such array. Then we can sort this array like 5, 5, 4, 4, 3. And then we can take like 3 elements from this array. Like first of all, we take the maximum 3, for example, from here, and no, it would not work like this. Okay. Mm, 14, 5, 5, 4. So we take index 2, 3. Yeah, so we take index 2, 3. Yeah, so yeah, so what we can do is actually we have this array 4, 1, 5, 3, and 3. And we have array 3, 4, 4, 5, 2. So we check, okay, we have 4 and 3. So we leave 4, 1 and 4, 5 and 4, 3 and 5, 3 and 2. So if we will merge these two arrays, we will get something like this. And then we can sort it. So we can sort like 5, 4, 3, 3, 1. And we can check, okay, I have 5. Can I take this 5? Yes. Then I have 4. So this one I sort. So, okay, I have 5. I can take it. Then I have 4. Can I take it? Yes, I can take. Then I have 3. 3. This one. Like, can I take it? No. This one. Can I take it? Yes. And as a result, I actually can take 5, so it would be index 2. Then 4, it would be index 0. And 3, the second one, it would be index 4. And the sum from here would be 12. Okay, then what I have? Then I just, here I just think iterate this another array, so I can just sort it's 4, 5, 4, 4, 3, and 2. And I can go through this array and check if I can take like 5. 5, it's on index 0, 1, 2, 3. So I can take 3. Then 4. Can I take 4? So first 4, it's on index 1. So indeed I can take 4. Then I can check another 4. So 4 is on index 2, so I cannot take it. Then I check 3. 3 is in index 0, so I also cannot take it. Then I check 2. 2 is no, 5. It's index 0, 1, 2, 3. Then 4, it's index 1. Okay, and in this case, I cannot take more, I think. Right? Because I already taken. I can't. Yes, I cannot take more. So I can take only 5 and 4. So it would be 9. And yeah, 12 plus 9 would be 21. Yeah, I think it should work like this. So let's try to implement it. So what I need? So first I need this kind of array. So let's call it merge array. Then it doesn't matter what length it have. Let's say it have length like this. And yeah, we already have this thing. So our merge array will have I. Here we have maximum of reward I and reward to I. Okay, so here we have this merge array. Then we sort pairs, right? Sort pairs. And after we sort these pairs, we check if we can take. So we check 5. Can we take 5? So we check if yeah, but it can be like, it's always like this. Okay, so let's do it. So we take our pair and we add to resultant index only if our P, our merge P index is less or equal. It cannot be less, right? It can be only greater. So if only equal to merge P is equal to P value, then we can take it. Otherwise, not. And we are going not by K, but we are going through all indexes. Through all indexes. And if our indexes size is equal to K, then we break from here. And here, if our indexes size is less than K, then we go once again we go once again, and now we are checking P Yeah, so we just check if indexes contains yeah, we should take the maximum, right? So here it's interesting. Like what other values we should check and take. Let's try to take which one we don't have, like indexes contains I false. Okay. Okay. No, it should be p index. Yes. Okay, let's try to run it and use this test case. So we have this one, this one, and 3. Let's try to run it. So I think there could be some test case where, we are taking something different. And I think for this test case, actually, we are going here in this if block. So let's call it to be sure that we are going here. Yeah, we see that we are going here, and actually we see that we can take only one element from here, like 6, because all other elements are greater 1. And if we are taking this 6, then we should check so can I have this one? Yeah, so rewards are the same, I think. Yeah, the 2 lengths are the same. So I think that here I should also add another index. So if R is the same, I should do the following. Yeah, I should have this one, and here I do this one, format, and in else I do something different. So if our indexes is small, and I already added some index, I should add k indexes from here, and then add another one from here, like for example, if I have 6, this one, then I can take only 6, this one 6, and omit this one. And here I can take 4. Yes? And I actually can, what I can do, it's sort by minimum. And yeah, I can have another set with indexes here, indexes 2, let's say. And I can sort yeah, this else probably would still be needed. So it should be like this. Yeah, so I have another set. Then I have this pair 2. Let's call it pair 3. And I get it here. Then I sort this pair 3 like this. Yeah. And what actually I'm doing, so I have this sorted backwards and this forward. So I can check what other keys I can add into my reward, right? So for example, here I have 6, so I cannot get like added to my reward, but I have sorted this one, so I can add it. So so I'm going like while indexes size is not equal to k, I can iterate like this one. And I can take from this pairs this pair, right? And here my pair would be pair index, and I can check if indexes contains false no, have sorted, right? No, should be not like this. I should take from sorted indexes 1. Where is it? Yeah, this one. It would pair 1 and this pair 2. And I can check if P1 I can take index and indexes contains false. So if I don't have this index and and reward 1 p1 index is yeah, I think that it's so quite complicated, and yeah, probably I didn't solve it. So let's try to check. Imagine first the second mouse eats all the cheese. Then we should choose key types of cheese with the maximum sum of reward to apply reward. This creates a little confusion. Yeah, that's true. Okay, so we have points, reward I minus reward 2, and points plus reward 2. Pick top key minus reward 1. Yeah, so we actually update our first reward with minus this one, and we add into our points all second first, and then we remove then we add to our points reward and minus 1. So we sort it and points dodge and login. So greedy with detail and easy understanding math proof. So pick its cheese reward 1 from n equal to key. We can prove it to total points. Yeah, really nice. So I like this solution. Priority queue. So we can generate priority queue and push the difference answer and take top. Yes, so they have all the same logic. We use an index array and we sort it by R1 minus R2 descending. Then we take k values from the first array and the rest from the second one. Yeah, this one is complex one. Okay, so what here? List pairs. We add the difference. Okay. Then we compare by key. Okay. And then reward get value. And get value. What if we have all rewards 1 negative? And if we have negative, it's really interesting. Yeah, because let's imagine that we have such example, like on first we have this one, and here we have this one, and we have k equal to 2. So in this case, we have difference 1 minus 5, it would be minus 4, then minus 4, right? Then minus 4 and minus 4. So all the difference is actually 4. And they all have the same difference. And what are we going here? Key answer size. Yeah. And actually, it doesn't matter like what. It doesn't matter like what we will take. Like if we would take, for example, here 7 and 8 and 1 and 2, or we take 5 and 6 and 3 and 4. So if we will take a look, here it will be 18, and here it will be also 18. So it doesn't matter actually which one we will take, because they all have the same difference. But what if we have like something like this? So here we have like -5, and this -5 would be go here, and yeah, and in this case we take this 2 and then this 2, because 7 is greater than 2. Then for sure we should omit this 2. Nice. I think that it's a really good implementation, so I think we can use it. But it's all for today. Thanks, and have a good night.